People use it to go to sleep and they feel better. But as an NAD ACE or CD8 inhibitor, it's extraordinarily, the potential is huge. So I think everyone should be on it.
Why don't you just skip the NMN and the NR or NAD and injectables and then just take Apigenin and not have the CD38 eat up all your NAD?
Because there's no evidence to suggest that alone is going to do the trick. I'm a big believer of polypharmacy and polypathway. You
Mhm.
block what you can and you add back what you can.
All right. Well, it's a real pleasure to have Dr. Sandra Kaufmann with us today for, I don't know, the billionth time. My favorite guest. Welcome, Dr. Sandra. Welcome.
Yeah, I'm happy to be here again. I don't think it's billionth though. I think that's a little bit of an exaggeration, but it's always regardless.
Oh, I guess, but you were from the beginning when I think was like episode 10 or something like that, like nobody. And you took a chance with me and I was so excited. You were one of my first celebrity guests. So I appreciate your support and you're still here and still supporting. So thank you so much from a personal level.
Oh, my pleasure. Because you say things like celebrity, and then my ego gets elevated, which is garbage because I'm not a celebrity. But I appreciate the strong, kind words. Anyway,
You are super passionate about longevity. It's very clear. You are, I would call you an expert in supplements because you are. You just take deep dives into things and you love to slow down aging. And you wrote books on it and have just realms and realms of information on it online as well. And you've got training in cellular biology and a medical practice and anesthesiology. And you're really interested in taking deep dives into things, into whatever it is that you're passionate about. And you're also my go-to for things because you're not really selling anything. You're not selling a supplement, but you should probably at some point because you just take these deep dives. But now you took a deep dive into NAD. And when I saw you, I guess it was in June last year, started telling me about it. And I think, oh my gosh, we have got to do a podcast episode on this because when you take deep dives, it is serious deep dives. And I learned so much from you. So maybe before we start, we'll do a very quick 101 on what is NAD, what is this molecule, and then why we may need it.
you're right. I do sort of take these abysmally deep, ridiculous dives. And the reason I do it is because I just want to know everything there is to know without anyone else's opinions in there. In fact, someone yesterday asked me, "Oh, well, who do you go to for opinions?" And the answer is, I don't. And it sounds a little snooty, but all I do is read literature and then attempt to form appropriate therapeutic direction from common sense medical applications of facts. That's all I have. But anyway, that is the basis of my deep, ridiculous dives that I do get completely carried away with. Anyway,
You do a lot of research. Obviously, you know how to read PubMed studies and everything, but do you read books as well or listen to other podcasts, other people talking about it?
a one,
Wow.
not a one, because I don't want to be biased in any way, shape, or form during a deep dive. I don't want to think, oh, Joe Schmo thinks this, therefore my opinion is tinged.
Hmm.
Everything I get comes from just deep reading. And I'm surrounded by physicians all day. So it is not unusual for me to say, oh my gosh, I was reading XYZ. And then at the hospital cafeteria, for example, I'll say, hey, to all of my molecular cellular buddies, what do you think about the suggestion of blah, 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 blah? And then we'll toy with it for a while and you think about pros and cons. And usually they just think I'm awfully nuts because of this longevity business. But we're all intrigued by cellular pathways and medications and way to intervene, et cetera, et cetera. So I don't work completely in isolation. That sounds a little bit nuts. But I don't listen to other people's opinions in terms of books and podcasts because I think people are slanted by many, many exterior factors, money,
Hmm.
popularity, commercialism, et cetera.
That's so good to know. And I'm glad everybody now knows where you're coming from. And they can then make their own opinion as well based on what they hear. So, what is NAD?
NAD. So I love molecular biology because molecules tell you exactly what they are. So NAD is nicotinamide adenine dinucleotide. And when I do this as a presentation, I show the big giant molecule, and all of those three pieces are in different colors. So The nicotinamide is a nice molecule that can get taken off. The adenine is a molecule that can taken off. And then there are two nucleotides. And so what the body does is it can use the molecule as in a complete whole, or it can disassemble it and use all of those pieces and parts to fix other things. And we use both of those mechanisms with the NAD molecule. But I always like to start out with a few silly little factoids. So cocktail party question. So the molecule is labeled as NAD plus, right? You see that everywhere. And actually it's NAD minus. If you look
Really?
at the molecule itself, there's two negative phosphates on it. And there's a positive on the nicotinamide molecule. But in total, the molecule is negative. So I decided that NAD had a fantastic PR agency that turned their negative into a positive, which I just it's silly, it's irrelevant, it doesn't matter, but it's just a fact,
That's
right? I mean,
crazy. Yeah,
right? So,
absolutely nuts.
silly. Second thing you need to know about NAD is it is a very short-acting molecule.
Mm.
The half-life is anywhere between 15 minutes to a couple hours. Very, very short. So the idea that you can store it up doesn't really hold true completely. To a certain degree, it can, but not entirely. Like you can hold the pieces and parts, but the actual molecule itself is very short acting. And the reason it's short acting is because it's part of our circadian rhythm system. NAD is made in a circadian fashion and it controls your circadian rhythms. So if you have low NAD, it's one of the big reasons that people as you age don't sleep very well. The myriad of other issues as well that sort of happen. But it is absolutely essential to understand that as part of your circadian cycle, therefore, when you take it is important, how you take it is important, because what it's doing has extreme ramifications downstream. Another cocktail piece of trivia, you have 3 grams of it at any time in your body. So if you
That's
want to,
it?
that's it. So if you want to grind yourself up, you will find 3 grams. And that's for a standard 70 kilo person. But of course, we know that no one is actually standardly 70 kilos, but that's a medical thing. But we are constantly making the molecule, breaking the molecule down, and then resynthesizing it. It is a constant state of flux. And we don't know in humans, but we do know in mice or rodents that you turn over your NAD pool 3 times a day. So it is a very, very active, dynamic molecule.
You're renewing your pool 3 times a day. You mean like
Oh,
all getting
rodents are. Rodents are.
Oh, rodents. Okay, sorry.
Rodents are. I do not know in people. We've never measured it,
Mhm.
but we can assume that it's probably similar, but not maybe not exactly similar, right?
Okay.
And we're not rodents. And there are a lot of places where things that happen in them do not necessarily hold true in us. But as beings that use NAD as an energy base, it is probably likely that we turn ours over a lot as well.
hmm Okay. Interesting. Okay. So an NAD, as I understand, is so important and vital to the body that if we didn't have it for 30 seconds or whatever it is, some very short period of time, we'd all be dead. It's just you need it, no?
Yeah, I don't know, 30 seconds or so. Plus, you have death is hard to describe. That being said, yes, it is extremely important. And I'll tell you why. Okay. What do we use NAD for? So you have to divide the uses of NAD into two piles. Pile one are redox reactions. And this is where the NAD molecule accepts or gives out protons and electrons. So it's a shuffle game of that, just protons and electrons. And you see the reaction is always NAD plus to NADH. Protons, electrons bounce back and forth. But if you added those two together, the summation would always be the same, right? So we're not destroying the molecule at all. We're just using it as a transfer agent in category one. All right.
Mhm.
And all of those because energy transfer is necessary when we're making energy. So you
Mhm.
find it in all of the things that are involved in that, mostly in the mitochondria. So we use it in the electron transport chain, right? It's part of complex one. So that's very important. We use it 3 times in the Krebs cycle, which is in the matrix. It's like the soup of the matrix where we have like the whole chemical reactions. If you look at it like in a diagram, it looks like a circle. Of course, it's not really a circle. It's a soup with things that are bouncing around, but it occurs 3 times in that. And we also use it in glycolysis. Glycolysis is glycolysis, so it's breaking down sugar. So in the process of turning a glucose molecule into molecules that are actually smaller and easier to put into the mitochondria, we're also using NAD. So if you are short of this molecule, your energy system is going to falter, right?
Mhm.
So that's the big oxidative reductive pile of why NAD is important.
If somebody's feeling really fatigued as they're getting older, could we blame it on the low levels of NAD, or do you think it's just much more complex than that and many other things could be?
I think it's multifactorial, but that is the lowest hanging fruit. And I will tell you, I have a lot of clients that come to me in their mid 40s. NAD levels start to take a dive, usually by the time you are 40, statistically. And also, if you have health issues, it uses up a lot of NAD. So, absolutely. So, women, they're exhausted. We start getting them their NAD on a regular basis. Within, I don't know, 2 weeks, 3 weeks, 4 weeks, they feel significantly better. So yes, it is part of of energy.
Mhm.
Absolutely.
Yeah, it seems like everything declines as we age. Spermidine, melatonin, NAD.
Everything good goes down, everything bad goes up, right? That's unfortunately.
Well, let's say there's many ways to increase your energy during this menopause transition. For example, let's say get your hormones on balance or check your thyroid or maybe check your B vitamins or whatever. So if you're taking other protocols, let's say, to get more energy back or even exercise more and create more mitochondria. So then there must be a role that NAD is playing in each of those
Right.
treatments, no, or is it totally separate?
No. So you have to think of it as layers, layers of complexity. And I like to think at the very, very base of our bodies are cells. And if I was a cell biologist, I'd say, oh, no, no, no. The base is obviously a protein or whatever. Like it's smaller, smaller, smaller. But in my world, as I was trained to start with as a cell biologist, cells are it, right? So if your cells are not working, nothing else that your cells do are going to work,
Mhm.
right?
Yeah.
So let's say you pick any particular cell, and this one particular cell makes estrogen or testosterone or thyroid. If that cell doesn't have the energy to make that hormone, it's not going to,
Mhm.
right? So then people take accessory stuff to substitute it in. And they go, oh, well, my hormones are great. Well, because you're faking it, right? If you can actually go to your original cells and optimize your original cells, they may make everything you need without having to supplement it.
Yeah.
So I start at the cellular level of optimization. So when people come to me and they go, their levels are low, I don't immediately go, oh, you need hormones. Oh, no, no. I say, let's fix your cells. And of course, back in my world of the 7 tenets of aging, cells fail for innumerable reasons. And we hit the lowest hanging fruit first. We activate sirtuins and AMP kinase and ta-da-da-da-da. I've had many lectures about that. And NAD is one of the absolutely lowest hanging fruits in terms of cellular optimization. It may, in fact, be able to replace needing to supplement with other medications and hormones.
I guess nobody could argue with that in the sense that yes, cell optimization. I mean, you're getting to a cellular level, and that's what our bodies are made up of. So, how do you do that? It's just maybe many ways to skin a cat. But NAD, okay, people may turn to NAD supplements or injections and things like that. But before we move on to that, why do you think it's important for a woman who's going through the menopause transition to improve and optimize her NAD levels or optimize her cells?
Right. Well, we're skipping ahead. And so I'm going to interrupt you there.
Mhm.
We got to the first category of what NAD
Oh,
does.
yeah. Oh, that's right. You said there were different categories. Yes.
Category. That is simply category one, right?
Mm.
Category two is when the molecule gets taken apart and different pieces and parts are used for other reactions. Okay.
Hmm.
And there's lots of these. In fact, it's called being a cofactor for different enzymatic reactions, of which
Hmm.
there are over 500.
Oh, wow.
Not just one or two, like 500 different ones. All right. And the two famous ones are PARPs and sirtuins. And even in the PARP family, there's 17, there's the family of of PARPs is 17 members, and there's subcategories within that. In the sirtuin family, of course, we've got 7 mammalian sirtuins. But
Mm-hmm.
so this is what's just the top of the iceberg here. In terms of PARPs, what's a PARP? This is all cellular biology. They're poly-ADP ribose polymerases. There's a word for you, right?
That.
Right? PARPs. We'll just call them PARPs for fun.
Parps. Sounds like farts, but we'll
Exactly.
call them parps.
PARPs. PARP 1 is the most famous. Okay. What does PARP 1 do? It fixes your DNA.
Hmm.
Okay. So when your cell notices that it has a DNA problem, and I will tell you that you have 10 to the fifth DNA errors per cell per day. So it's a
Wow.
lot.
Yeah. Yeah.
The older you are, the more you have. Your cell goes, oh shit. And it calls the PARP over. And the PARP goes, oh yeah, we got a problem here. Call in the help. So it builds chains out of riboses. Where does it get the riboses? From NAD.
Mm.
Pops off the nicotinamide, right? Nicotinamide, what is it? Nicotinamide adenine dinucleotide. It takes these dinucleotides, glues them together, the adenines actually, adenine dinucleotides, glues them together, creates a chain, and that chain is used to fix your DNA, right? It's
Mhm.
like a patching.
Yeah. Yeah.
So what happens when you don't have enough NAD? You don't fix your DNA. What happens? Then you get disease and then you get cancer. So that's a
Hmm.
problem. That's the PARPs. And again, there's 17 of them. That's just PARP 1. The second class of things where it's extremely important are sirtuins.
Yeah.
Sirtuins, right? You have 7 mammalian sirtuins. These are histone deacetylases. Not that that matters, class 3, random details. But what they do is they serve as on-off switches in your cells, and they basically control all cellular homeostasis. Everything from where you store fat, when you're going to go to sleep, when you're going to repair your DNA, what energy source you're going to use. You're going to use glucose, you're going to use some cholesterol, you're going to use some fats, what are you going to do? All cellular homeostasis controlled by sirtuins. Sirtuins don't work if you are NAD deficient. Okay.
Okay.
And then of the 500 different possible needs or reactions that require NAD, right? You say to yourself, well, who gets what? Who gets dibs if you've got a significant deficiency? And it turns out it has to do with something called binding affinities. Like what is more likely to grab the available NAD first? And it
Hmm.
turns out that sirtuins are terrible at it. They have a very low binding affinity.
Hmm.
So when you have less NAD, your sirtuins don't get their fair share and you lose all cellular homeostasis.
Mm. And then that leads to problems again, like DNA repair, no?
Loses everything. So your sirtuins, you've got 1, 6, and 7 are in your nucleus, 3, 4, and 5 are in your mitochondria, and 2 sort of flits around the cell, controlling everything. When you experience severe cellular dysfunction, everything goes bad. It is the root of every age-associated medical problem that there is. So on one hand, right, you've got your pile of NAD, right? We talked about category 1, where it's just used as for energy. Category 2 over here, we're using the molecule to take it apart. And one would think, okay, well, we've been doing this our entire lives. Why is it a problem as you get older? As it turns out, the enzymes necessary to make NAD, and we can talk about that in a minute, decline. The pieces and parts to make it decline, and the usage of it goes up. For example, you have more DNA damage as you get older, so you need more NAD, so you're burning through it. And we'll get to
Mhm.
CD38 in a second, but that again eats up more NAD than it used to.
Yeah.
So as you need more, you have less, and all of these systems shut down.
So you said these categories, one of them is for energy transfer, and then the second one is to take things apart. Is there another part to this where they put it together again or recycle it?
All right, so there's pathways. So making of NAD, right? Your body can either make it from scratch or recycle it. And this is
Mhm.
where it puts itself back together. And this is a whole, and I'm going to use a whole lot of hand signals because in my brain I'm seeing like the slide that I always put up. All right. So you can, if you're going to make NAD from scratch, you start with tryptophan, which is an amino acid,
Mhm.
and 8 enzymes later, you get up to NAD. It is a very expensive system. It's very hard to do. Not many tissues do it. But the kidney, it turns out, loves this mechanism. And if you are tryptophan deficient, your kidney can suffer because it can't make its own NAD.
Is that
So
the only, but that must be other places that we make NAD, no? Other than the
stuff,
kidney?
that's just the original how you make NAD from scratch.
Mm-hmm.
Everything else comes from food or you're internally recycling it. Okay.
Mm. Okay.
The internal recycle system starts with your NAD molecule, right? It's just sort of sitting in the center. When either sirtuins or PARPs break it down, you can
Mm-hmm.
break it down into many pieces and parts. The most common thing to break off is the nicotinamide. It's just the NAM. All
Mm-hmm.
right. NAM then gets reprocessed into NMN, and then NMN with a different enzyme then gets reprocessed into NAD. So it is a two enzymatic step to go back to creating the NAD molecule. All
Mm.
right. Things to know here. When NAD breaks into NAM, and NAM can actually have negative feedback to the sirtuins and your PARPs. So if you have a big giant flood of NAD, such as in an IV infusion, right? It breaks down very quickly because it's a short-acting molecule, right? Half-life is very short. You get a
Mm-hmm.
huge amount of NAM, and NAM is a negative feedback inhibitor of sirtuins and PARPs. So you don't want a big giant load. Anyway, once you have your NAM, then goes from NAM to NMN via something called, God, my brain. It just went poof. I'm not going to think about it. NAM? No. NAM. NAD. Oh my God, my brain. Crazy.
It's okay.
Okay. Okay. So the NAM then gets recycled into NMN using an enzyme called NAMPH. NAMPH, it turns out, is a rate limiting enzyme for the production of NAD. And as you would guess, it's very important, we have less of it as we get older, which kind of sucks, right? Of course. And if you are fat, you have less. If you are inactive, you have less. It's as if your body says, we don't need any more energy. We're good. Just stops making it. The other interesting thing about this enzyme is that it's driven by circadian rhythms. So it only produces the NAD when your body needs it as it naturally peaks and flows. So that's kind of cool. Anyway, so NAMPH creates NMN and then turns back into NAD. And this is through an enzyme called NAMNAT. And there's three isoenzymes of NAMNAT. And the cool thing about NAMNAT is that it has dual functions. It's also a protein chaperone. So
Okay.
it's really cool. So for certain shock, it's not a heat shock protein activator, right? It's a chaperone. So for certain proteins, it is a foldase and a holdase. So
What's that?
it causes proteins to accurately fold into their three-dimensional conformation, and then it just holds them there so that they're better. So
Hmm.
I always think of the Kenny Rogers song, like no one to fold them, no one to hold them, no one to walk away. Great Kenny Rogers song. So NamNat loves Kenny Rogers. Oh, no, NamNat. So it's a chaperone as well as being very important for the NAD creation. Anyway, whatever. So basically now remember if you're going. So to recap, we're going from NAD to NAM to NMN back to NAD. That's our basic triangle, right?
Hmm.
And then people go, well, what about NR? Where's that?
Yes,
So
I was just
right,
going to ask that.
right, no, I get that. I get that. So NR gets converted into NMN via something called NR kinase.
Mm.
So there's enzymes that drive all of this in circles, right? And
Mhm.
what's really interesting about this, and people go, well, which one should I take? And ultimately we'll get to the conversation about which one to take. But the important thing to think about is that the presence of these enzymes in various tissues will drive preference of tissues.
Okay, depending on which enzymes you have, will probably, that's what you're saying, which enzymes you have will give preference to where things are going and which, I don't know, your
Yeah.
muscle or your cartilage
Right.
or
So,
skin.
as an example, right?
Hmm.
mu- Skeletal muscle has a lot of NR kinase.
Hmm.
Therefore, it loves NR. You throw NR at muscle and it goes, yeah, baby. Converts it to NMN, throws it into your NAD cycle, and voila, you got a lot of NAD, right? Other tissues don't have as much NR kinase. So you put it in, you go, eh, not so great.
Hmm.
The retina loves NMN.
Really? Okay.
But
So,
here's
yeah.
the snafu. If you give someone too much NMN and you don't have enough NAMNAT to convert it, it becomes toxic and can cause axonal degeneration.
Oh,
right?
great. Great.
Exactly, right? So you go, oh, that's not good. So either one of two things, you take a little less NMN, or you could upregulate the enzyme, and you can actually do that with green tea, which is sort of a cute little fun thing to do.
Or
But
EGCG, like as a supplement?
yeah,
Okay.
EGCG upregulates NAMNAT, which means
Okay.
it's also upregulating your chaperone, your Kenny Rogers chaperone here, right?
Yeah.
And it makes NMNB less toxic, which is kind of cool. But the point being is that different enzymes have different, or different tissues have different enzymes, and thus different preferences for different precursors of NAD.
So that debate, should I take NMN or NR? It depends. And actually, and we don't know, maybe your muscle prefers the NMN and my muscle prefers something else. General, you maybe say muscle tissue, but maybe your tissues and my tissues would be different.
Well, I think our muscles are going to be generally the same, and our muscles are going to be like, we really like NR. But maybe our other tissues don't like it as much. Why? Because they don't have as much NR kinase.
Yeah.
Maybe our brains and our retinas do better with NMN,
Yeah.
but
Yeah.
not too much. And here's the other snafu. It depends on as well so as these things are floating around in your vasculature, they have to get into cells
Hmm.
to do their thing. And it turns out that different cells have different receptors to allow things into the cells. The only cell type that we know of that has an actual NAD receptor on it is a neuron.
The only cell that has an NAD receptor on it is a neuron. That's
Yes.
okay.
So when people
That's
do,
your brain, just so people know this is your brain
that's your point.
cells.
So when people do IV infusions of NAD, I am staunchly opposed, except for the treatment of brain disorders, because you're basically getting it through your blood-brain barrier and it is going directly to your nerve cells, and it does wonders for traumatic brain issues, depression, all of those things. It's great for brain disease, but it doesn't get into any other cell directly,
Mm,
right? It
hmm.
has to be metabolized to something that has a receptor, right? NMN has a receptor. NR actually has a bit of a receptor. Tryptophan has a receptor,
Hmm.
right? Otherwise, the NAD has to get broken down into NAM or some other pieces and parts, gets put into the cell, and then reconfigured to be NAD again.
If you said that the NAD, the only times that you think NAD would be really great, straight IV, I guess, is for the people with the brain issues, but you just said that it has a half-life and it's very short and short-lived. So are they really benefiting is the brain for these patients really benefiting from this?
So people claim that they have. All I
Mhm.
can do is tell you via research papers that that's the subpopulation that does well with that.
Well,
For everyone else, it's not worth the IV.
yeah, but but I'm like, they feel benefits. I'm wondering in these studies that you're looking at is they feel great for a day, they feel great for a month, they feel great for a year.
Excellent. It's an excellent question. And the answer is I don't know.
Yeah.
It depends what the cell is doing with the NAD. Is it just using it up transiently for energy, or is it using it to rebuild tissue?
Yeah.
These are questions I can't answer for you.
Yeah, this is, and we had this discussion ages ago in our other one of our episodes, and you mentioned, I'll never forget it, that yeah, because it's such an expensive thing to do is get an NAD IV, is it really worth it? Short-lived. And no doubt, I know plenty of people who love it, they feel great, but again, it's so short-lived. So is it really worth the money for that, unless there's some other long-term benefits you're getting? But usually the people I'm seeing is I feel energy, but it's quite short.
Yeah. Well, and the other interesting thing, right? So the more NAD you give in a very short-term place, right, it immediately gets converted to NAM. NAM is negative feedback loops. And the other really interesting thing about NAM is that it gets methylated. It loves to get methylated. And
Hmm.
interestingly enough, if you have enough of it, it sucks up all of the available methyl groups and actually can precipitate some significant epigenetic changes in a negative fashion. Consequence of that, some people say, well, then their answer is giving betaine, which is trimethylglycine or trimethyl. It's basically, yeah, it's trimethylglycine. So that you're putting the methyl groups back to replace the ones that you just sucked up by too much NAM. So it's little bit like chasing your tail.
Hmm.
So
Yeah.
my thought is always you want NAD and you want to supplement it appropriately, but you don't want to give too much at any one time to cause detriment, You know what I mean? You also want to replicate the endogenous pattern. And it turns out the endogenous pattern is that it peaks like in the mid-afternoon of every day. If you measure levels of younger people, it's higher than old people to start with. And then it peaks mid-afternoon, comes back down, peaks mid-afternoon, comes back down. So if you read on the package of NR, NAD, whatever, to take it in the morning, that's wrong. You
Hmm.
don't want to do that. Right. And then people go, oh, well, it's going to take time to metabolize. Fine. If you're taking an oil supplement, do it a half an hour before mid-afternoon or something. Or if you're taking it IM, great. It's immediately in your body. Do it at midday. And the other thing
I
interesting,
am meaning intramuscular, right?
IM or
An
sub-Q. It's
injection,
basically
like I mean, in an injection, yeah.
And now the interesting thing about straight up NAD, right, is if you take it by mouth, it's not going to get into your body, right? Because it can't get through any cells. They're trying to show me some evidence where if you liposomalize it, maybe it can get through the intestinal cells and then into your bloodstream. I don't know if that's true or not yet, but I know someone's working on it.
I understood that the molecule is just too big to get into the
It's
cell.
nothing to
So,
do, it's nothing to do with size. It has to do with receptors.
okay.
Right? It's a big molecule. Molecules need receptors. They need special doors to get through.
So
There's
it
no
can be still
door.
big, but as long as it has the receptors, you think it could still get into the cell, even though it's
Of
large
course.
in size.
Of
Okay.
course. Absolutely. Absolutely. What was I going to say? Ah, yes. So people go, well, then IM or I or whatever NAD freeform is pointless, but that's not true either because extracellular NAD is actually quite important. And we use it as a neurotransmitter. Like your gut uses it as a neurotransmitter. So some people that are NAD deficient, their gut doesn't move as well as it should. It's a signaling molecule. So extracellular NAD is very important. So when people do it IM sub-Q, as I said, it's straight up NAD. It actually is quite beneficial. You don't need a ton of it, but it's beneficial. So my argument is always you need a combination of these things to address all of your tissue needs without overdoing it. So that's sort of like the precursors and what to take. And we've sort of ignored, and we'll get back to then sort of blocking pathways that shouldn't have it. And there are several. I think the most important is CD38. And what CD38 is, it is a surface molecule. Most of the time it's a surface molecule. There's a few floating around that are soluble. But most of the time it sits on the top of a cell on the wall, usually immune cells, maybe some endothelial cells. And it's triggered by inflammation and it eats up NAD.
Hmm.
And it just turns the NAD into byproducts, including NAM. It's called an NAD ACE. All it does is eat up NAD. And
Hmm.
that triggers more inflammation. Huge inflammatory component. So the cool thing is, so if you block CD38, you're blocking both useless using up of NAD as well as increasing the inflammatory process. You'll never block all of it, but blocking a large part of it does two great things. So you go, well, that seems like a no-brainer. So the question is, how do you do that? At the moment, there are only a few things available that can do it. Well, only one thing truly available that could do it. In the drug world, in the experimental drug world, SmithKline has something out called 78C, but I've tried to get it and I can't, and it's an NADase inhibitor. The only thing available to us truly is apigenin. Comes
So
from tea. People use it to go to sleep and they feel better. But as an NADase or CD8 inhibitor, it's extraordinarily, the potential is huge. So I think everyone should be on it
why don't you just skip the NMN and the NR or NAD and injectables and then just take Apogena and not have the CD38 eat up all your NAD?
because there's no evidence to suggest that alone is going to do the trick.
Okay. Okay.
I am a big believer of polypharmacy and polypathway, right? You
Mhm.
block what you can and you add back what you can, which does not mean, so I use significantly lower doses of things that's always on the package. I'll use a third of a dose or a half of a dose of whatever they recommend. But then again, I'm using several of them at a time, as well as CD38. Because I
Mhm.
also think that I think the only test right now that is Ginfinity-ish that can test NAD levels. And I am completely convinced that it's not exactly accurate. Like the poor guy, I'm sure he's going to yell at me for saying that. But, but
But wait, you can't
everyone
test.
comes back to me and says, oh, the levels say that I'm super, super, super low and I've been taking this forever and blah, 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 blah. I don't think we necessarily need the levels that he says we need. I think you need good levels. And I think your body, if you have energy and things seem to be going well, you're probably reasonably sufficiently loaded. But then again, the older you have, the more deficient. The older you are without supplementation, the more deficient you're going to be.
Yeah. But I don't understand how you can test this because as I understand you, it's kind of like you got to be in a lab because if you were to take your NAD from your own body, you got to really analyze it in 2 seconds because it just degrades immediately. It doesn't have, it's very fragile, no? And
It is pretty fragile. They swear that they can do it. I've had mine measured, and after years of supplementation, they're like, "Oh, you're very low," which I'm like thinking, I don't know if that's true.
no, no.
Look,
I mean,
the
I
and
think,
the other thing that's really interesting is they don't ever keep track of the time either. So
what do you
if your
mean?
levels are oscillating throughout the
Yeah,
day,
yeah, yeah.
right, you may be testing it when it's super low, and you're
Mhm.
actually high at the right time. So
Yeah.
don't think our methodology for measuring it is all that accurate yet.
As far as I was waiting to see if you found some. I think everybody's waiting to see their how to test your NAD. I think that's ultimately the best way to find out if you're deficient in something. Then, well, the test, measure, and assess. To do take a supplement or do some new protocol and repeat. And but NAD is just so difficult to know. And I don't know if somebody feels like I've got plenty of energy. I feel really great. I do a lot of things for my health. But does that mean I got great NAD levels? We don't know, right?
Yeah. We
They
don't
could
know.
still be very low. Like you also have tons of energy doing so many things, and to test this and tell you your energy, your NAD is low. On top of it, you're taking other kind of supplements and doing so many protocols. I can't believe it.
I was like, I just don't know if that's possible. But you know what? I don't know. And there's no evidence one way or the other. And I think you're right. If we were sitting in a lab, we might be able to do it like instantaneously and be like, okay, fine. At the moment, we just don't have that ability. So fingers crossed and we tread water until we get that. In the meantime, I just think we take a educated, directed, well-meaning attempt at trying to optimize our levels.
Mhm. And I think one measure would be great. If somebody is experimenting with NAD injectables or NMN and R, these supplements, or doing some other kind of protocol to the proof, I guess, would be in the pudding in the sense that they probably would feel better or they would see a difference in their health. And then they could maybe assume, oh, perhaps this is working to improve my NAD. And if it's not working, well, then move on to the next protocol.
Yeah, I mean, I guess I can just tell you that it is statistically likely that anyone over 40 is low.
Yeah.
It's just statistically probable. Not guaranteed, but probable. And the caveat to that, of course, is if you have anything that is increasing the requirement for NAD in your body, you will be more low because
Mhm.
you're using up more. And if people aren't sleeping, they're probably very low. Drive circadian rhythms. So that's a big indicator.
We've already mentioned taking supplements or doing injectables or IV, but what about other ways that we can improve our NAD levels to exercise or I don't know, fasting, or is there any other sleeping well? What else can we do to improve them?
Exercise is known to do it. Fasting, you're basically just using up less energy. So you're not using as much NAD. So you're not really boosting it per se. You're just not using it, right? Sleeping well, that's it. That's a circuitous argument,
Mhm.
right? You're sleeping because you have NAD, therefore you're making more NAD, right? If you're
Mhm.
not sleeping, it's because you're NAD deficient.
And you're eating up maybe more NAD because your body is trying to go to sleep. Maybe you're stressed out.
NAD drives circadian rhythms. It causes you to sleep, and the sleep makes you have more NAD, right?
Mhm.
While you are sleeping, here's an interesting sleeping conversation. 40% of your genome is active while you are sleeping because it's driven by clock and BMAL proteins. And this is when you are repairing your DNA, among a gazillion other things. Therefore, as you are sleeping and you are repairing your DNA, you are activating your PARPs, you are using up NAD.
Yeah. Yeah, because even when we're asleep, the body is using a lot of energy to do other things,
Well,
right?
it's specifically repairing your DNA.
Yeah.
And that specifically is using up NAD. So you could argue, I'm going to save my NAD and not sleep. But that's the right thing to do, right?
Yeah, but then you need more energy for more things. And I'd imagine then you're using up more NAD. You're just using less NAD maybe when you're asleep.
Yes. So the idea here is just let's just optimize it, right? If
Mm.
you optimize your NAD level, your body can make what it needs to make. You will sleep when you need to sleep. During that sleep, you will use your optimized NAD levels to fix all of your DNA. You will wake up bright, happy, shiny. Your skin will look great. You'll feel refreshed. Your brain will be clear. And then you'll remember to take your NAD supplements again the next day. And then we're good to go. It's just,
Yeah.
there's all these just self-fulfilling prophecies and cycles.
Yeah, that's in the end, we just try to do our best that we can. And in the meantime, we try to hack things and because maybe we're not so perfect and we don't do maybe as much exercise as we should, or we go through cycles where we're doing like me, I can't, well, now I'm starting to, but with 2 hip replacements, I couldn't move very much. So what do I do to still stay in a good condition? We have to make up for things sometimes when we just can't be there. So let's move to the conversation back to the CD38 and there's the NNMT, as I understand, is another enzyme that as we age and our levels decline, and then we have an increase in these degrading enzymes. If you, and then correct me if I'm wrong, the way I understand it is if you put in these precursors or NAD itself or the precursors NMN and R, you can potentially increase these terrible enzymes that are eating even more NAD. And I understand it. Like, for example, CD38 has associations with mitochondrial dysfunction, inflammation, cancer, et cetera, et cetera. So the game is to block those with apigenin. But I also understand that you can block the NNMT with 1-MNA, which is another supplement I've never heard of, but just to offset the damage. Is that correct?
To a certain degree, yes. I think that we are still working through that information. I am not comfortable yet making recommendations in that department because I have read different things about blocking it versus not blocking it, etc. So let's have another podcast in another 2 months, and I will be more than happy to tell you everything I know. But at the moment, I've just read a lot of conflicting stuff, and I need to solidify it in my head before I make a proclamation.
Okay, good
I know
enough.
that's a very
Thank you.
not settling answer, but it's the truth.
No, of course. And I think that in this world, it's one of those things I'm really scared about myself is when we always think take something, the more, the better. And then we could be doing potentially more damage. And so what I'm hearing from you is NAD can potentially be a really good thing. Precursors could potentially be a good thing. And taking it midday, mid afternoon, which would be around 2 p.m., more or less, is probably better if you want to sort of optimize it. And then the question would be, all right, if somebody, the big thing right now in the UK, I'm not sure about in the US, is injectable NAD or NAD plus. And again, I don't know the difference between NAD and NAD plus or slash minus, whatever it should be.
It's exactly the same thing. It's just the naked molecule.
Oh, okay. So it's
That's
not somebody saying I go NAD plus, it's different than NAD. They're full of BS.
it's exactly the same thing. It's
Okay.
exactly the same thing. And you can argue actually it's N18 minus, right?
Okay. Okay. I gotta get with this
Same thing.
argument.
And I know the people that make that, and they're very good people, and it's a very good product. And it's part of the armamentarium. It is not the end all be all, right? I
Hmm.
don't think you can get all of the stuff you need out of the IM injection. I think you truly need a combination of NR, NMN, the straight up NA, either liposomal, because they're working, that's the company that's also working on that, or IM, as well as apigenin, as well as some green tea. And if you're worried about hypomethylation, then some beet. I would
Biotine.
love
What's the biotine? I don't know what that is.
it's just trimethylglycine. It's
Oh,
just
that's
another.
the trimethylglycine, but that's supposed to just help it be more efficient in getting to the cell or something, not necessarily a blocker.
It's not a no. What basically all you're doing is giving back the methyl groups.
Hmm. So that it's
That's
more effective.
well, so that you're blocking the damage.
Oh,
Because
okay.
methylated nicotinamide sucks nicotine, just the nicotinamide from nicotinamide adenine dinucleotide. When it's separated, that molecule likes to get methylated. Just what it does. And it
Hmm.
absorbs the methyl groups, therefore leaving your cell methyl depleted. So trimethylglycine just puts some methyl groups back in the cell so that you don't have any issues with epigenetics.
So it's not vulnerable. Yeah. It's like protection. Got
Correct.
it. Okay. So let's say you're going to choose one of these ways of getting your NAD back. And then is it better to take this every day and keep going, or should we do it in pulses or for 4 weeks and then stop? How do you navigate this to make sure? Because, like you said, different tissues need different
Right.
molecules, right? So how would you navigate this space?
So well, in the optimal world, there would be a pill where it would have a little bit of everything in it, and you would take it every day at about 2 o'clock
Mhm.
with no need for pulsing, right? Because you need NAD all the time, every day. You just do. So you don't want to be deficient one day and then okay the next day. You just don't. So that would be the optimal way of doing it. Is anyone actually going to do that? No. So what I
Mhm.
tell people is I tell people, so for 3 weeks or so, take NR. The next 3 to 4 weeks, take NMN. In the meantime, maybe on weekends, inject it with NAD. So I have this goofy thing. I travel a ton. When I'm at home in Miami, I have NAD in my refrigerator and I
Mhm.
inject, right? When I'm on the road, for example, I'm in New Jersey, I've got my NMN. When that bottle runs out, I'm going to switch over to NR. But then
Mhm.
every weekend, I'm using my NAD. So I
Mhm.
try very hard to rotate them all to make sure all of my tissues are getting what they need.
Mhm.
Same time, every morning, I take a big dose of liposomal apigenin.
And the EGCG or green, or you drink green tea.
Well, actually, I don't drink it. It tastes terrible. Yeah, no, I
Oh, I
take.
love green
Oh,
tea.
it's terrible. No,
Ah,
I have my standard pill pack here,
oh,
and
yes.
the green tea is in there, as is the apigenin. That's yeah.
I
I mean,
know. Okay. Okay. So this,
well, it's 70 other random things, but
I
yeah.
know. You know, you are seriously supplement queen, and I learned from you. Yeah, we don't take them all in the morning. We can have our afternoon stack and our evening stack, and then we take, at least I do, like you, take half dosages or
Yeah.
a third or whatever it is, and then keep rotating. But I stopped because of one, I get tired or I get fed up or I just forget or I'm traveling and then I go back to it. But I think you're much more consistent than I am, and you've got your special stacks, which I can't believe I don't even have, considering I travel as much I do.
Oh, I need to send you stacks. I will send you stacks.
Those little stacks, can somebody buy those online from you? Because I know that you made these for a purpose to help people
No,
travel with their.
I have 5,000 of these silly containers. Absolutely. Originally, I had them made to sell at conferences, and then COVID hit. There were no conferences. I have a huge, massive these things, and I don't like to sell things online because then you have to worry about shipping. And so, if anyone wants them, all they have to do is email me, go to my website, email me, say I'm interested in stacks, and I sell them for like $12 or whatever. They can Venmo me, and I mail them to them. Like me, myself, and I go to the post office.
Oh, you're amazing. And you actually read your emails, which is
I do.
unbelievable. I cannot imagine. I know you get a ton. So yeah, just you take your NAD, make sure. Okay, so I think it's clear. Actually, you've given us a really good protocol, and to be continued because you still have
There's
research
more
to
to do.
do.
Yes, absolutely. And it was really interesting. So when I went down that part of the pathway, it just wasn't crystal clear. So I thought I'm going to take a step back, clear the brain, and then dive back into it. Because sometimes mucking with pathways is not as clear as it should be. Sometimes it is, and sometimes it's not. Blocking CD38 seemed incredibly clear, but other ones are not because not all pathways are good or bad, right? There's a lot of in-betweens. And
Hmm.
I just want to make absolutely sure that whatever information I disseminate is accurate, clear, and appropriate.
Hmm. The one thing about the NAD injectables, because I started and then I stopped because I got scared with the CD38 pathway and I didn't have the epigenin. And then I'm like, okay, wait, I got to do a little bit more research before I start injecting myself. So for me, it's a bit clear, but these injectables are very expensive. Mine was like $400. I don't even know how long this is going to last me. It's a little bottle, but that's, I think, the having it on the weekends or the way you've given it to us is actually makes a little sense. And I don't know if the popularity continues. Is it going to be still quite, is it going to come down in price or not? Because NMN and NR is quite reasonable.
Yeah, the answer is I don't know. I don't know how much it costs to manufacture it. I have no
Yeah.
blue idea. So I don't know what the markup is. I think
Yeah.
that NR and NMN have come down just because they're very competitive.
Yeah, exactly. So let's say then somebody is just doesn't want to be spending the money on the supplements and the NAD injections. Do you think that they can get reasonably good NAD levels with exercise and good sleep and nutrition and all that?
I doubt it.
I doubt it.
If you think about it, right? Let's define longevity medicine, right?
Yeah.
People have been trying to live forever since the dawn of humanity, right?
Yeah. Yeah.
A gazillion people who eat incredibly well and they exercise all the time. And you know what happens to them? They get old and die.
Yeah, but maybe the quality of their life is better.
I'm sure it is. I am absolutely sure it is. I'm sure they're
Yeah.
more active. I'm sure their brain is better. But have you ever met anyone like the guy there, I don't know, what is it? He like ran a bazillion marathons or something and then died of a heart attack, right?
Yeah, but that's extreme.
All I'm saying is that we've done the experiment of really good eating and exercise. And yes, people are healthier. Are they optimized? I don't think so.
Mm.
I love the example of pterostyl, right? It's a
Mhm.
sirtuin activator. When you get older, your sirtuins just drop. You lose cellular homeostasis.
Mhm.
You can exercise a lot and it's helpful, but you can't possibly get them up to the levels that you had when you were younger. But you can activate it with pterostyl. Okay, well, can't I just eat the natural product? And the answer is sure. If you can eat 3 gallons of blueberries a day, you are spot on, right?
I tried, believe me, it's not easy.
Yeah, right? You join it with like your 200 strawberries for the fisetin and your this and your that. You can't possibly consume all the stuff enough naturally to do it.
Mhm.
No, you can't do it enough via exercise. You can certainly be helped, but
Mhm.
you're never going to be optimized
Yeah.
truly unless you just break down and use sort of like the cheat method, which is what all this is.
Yeah. It actually sounds like our hormones and getting onto hormone therapy. Like, no matter how healthy we are, no matter how much we exercise and eat well, our hormones are going away.
Yeah.
And the only way to optimize them is to put them back. And of course, you can live well without them and still feel great. But are you optimized is a question. Are you protecting your bones, your brain, your heart, vagina, your breasts? I don't know. I don't think so.
It's exactly the same. And honestly, the only difference is that hormones are complex molecules made by cells. And I truly believe that if you are cellularly optimized, you don't need as much and you don't need it as early. But ultimately, it's going to fail. And ultimately, yes, it needs to be put back in your system somehow. And we've done the experiment. For hundreds of thousands of years, women have not had hormonal therapy, and we know what happens. Can you exercise enough to not be menopausal? No, we've tried that. It doesn't work, right? So you supplement when you need to. And
Yeah.
it's just another one of those things that there's no getting around.
Yeah. So, okay. And since we're all about health optimization, I think we all know what to do now. But the last question I have is I heard that niacin, and this is a supplement, that it's pretty much the best and cheapest way to get NAD since that's where everything ends up anyways. I don't know what your argument was that.
So anything that's a B3 vitamin derivative will do the trick. Niacin is perfectly capable of doing that. The only drawback with niacin is it tends to cause extreme flushing.
Yeah.
Makes people very uncomfortable. But it works. It's cheap and it works and it lowers your cholesterol. So if cost is a concern, yeah, absolutely go with it. You just may look a little flushed all the time.
Yeah. It wouldn't work with the non-flushing niacin?
I don't know. No one's ever actually tested it. It
Wow.
might. It might.
They've only tested it with the flushing niacin and it works, but we don't know with the non-flushing.
As
Mm.
far as I know from the studies I have looked at, that is accurate.
Just
Unless something got published yesterday and I don't know. But that is correct.
okay. So if somebody says, all right, I got to take niacin, like actually my doctor has told me take niacin, take the flushing one in fine. So if I were to take that anyway, I have to take it anyways. So is it just overkill to take the NMN and R and injectable NAD?
This goes back to the question of I wish we could test levels because if you are
Mm,
taking niacin, you might have absolutely enough. There is no way of knowing.
yeah.
And
Gosh.
it is significantly cheaper.
Yeah. Okay. Then can I ask you what brands that you're using for NMN and NR, NAD, injectable?
So the NAD injectable, I've been using NAD at home. It's a great company. It's UK based, good people, quality product.
And you can get it in the US? Oh, great.
Absolutely.
Cool. All right.
NR only comes from one company, so that's not so hard to choose. It's Chromadex. They make it all, so it doesn't matter where you buy it from. It's just Chromadex.
There's only one supplement company that makes NR.
Chromadex.
That's
Chromadex,
it?
but Chromadex is the company that makes the compound,
Okay.
right?
Okay. And they sell it to supplement companies.
Well, it's really funny. So they have their own, which is True Niagen, and they
Okay.
used, and then they got sort of bamboozled by Basis, which was pterosilbine and years ago. And then there was this big lawsuit, and then they wouldn't sell it to anybody else for a long time. And I think they're starting to again,
Mm.
but it's patented. It all comes from Chromadex.
Ah,
It doesn't really matter what company you get it from. It's just there's one choice. It's like Magtein or Mag-3 and 8. There's only one company that kind of makes it. And then in terms of NMN, anyone and the brother can make NMN. And I end up using something from Rev Genetics. Uh,
yeah, I've
it's,
used them.
it's a Florida company. The owner's a bit of a wackadoodle, but I think their brand is extremely good, competent. Their supplements are very well made. I tend to use their stuff.
Okay. Okay,
And
cool.
I
Oh
don't
my,
rep for anybody, so I'm not getting a dime for anything.
no, I know, I know. That's why I'm asking you. It's like, are you gonna?
But I'm trying to actually sort through different companies to see who does make the best stuff in all of the supplements. I'm trying to come up with a rating system for the companies. You source stuff, how clean are their factories, what's it certified by, is there third party testing? It's taking a really long time to sort of create that. And there's
Hmm.
no money in it other than just to sort of make sure I don't ever recommend bad companies.
Yeah, yeah.
Some companies are fantastic advertising, fantastic marketing, and then you actually look at their facility and you go, ooh, not so good.
Yeah, but then you have to go to their facility, right? That's
Yeah.
if you can do
Or
that, even
there's like
better.
a zillion certification programs and they're different around the globe. Like a lot of the supplements aren't FDA approved necessarily, but the manufacturing process can be certified by the FDA,
Yeah, yeah.
right? So they can say, anyway, so there's all of these gazillions of certifications. So someone is going into these places and checking. And then the question is, are the certifications available online? Can you get them? Do they
Yeah,
hire?
and you can also pay these third-party companies to come up with the result that you want. And there's also, I was actually today talking to a supplement company that reached out to me, and I'm trying to dig deeper myself. And so what they do is they have the third-party certification to show that what is inside the bottle is actually in the bottle. And I read their bottle of spermidine, and it's a synthetic because 8 milligrams. I'm like, wow, that's high. It must be synthetic. Yes, it's synthetic. So where are the studies showing that this actually works? I don't know. We have them somewhere. It must be, I don't know. I'll get back to you. And that's to me already a red flag. But it's hard to what questions do you, and I am no expert and I'm like trying to weed out, but there are some basics I think that we can call a company and see how they respond. But ultimately, sometimes like if they're going to come back to me with some study that shows their product is efficacious, then it's also like, how do I not know they've paid the company or the lab to actually come up with these results? Like just throw out the bad results. Let's just keep the good one. Or it's really hard to tell. And then on top of it, when it comes to spermidine, we know that the research that is out there is done on more natural stuff, not on the synthetic. So just
Oh, I know. No, it's a very complex system, very complex. And it's funny because it's almost like companies that make one thing, I seem to be better than the companies that make 67 things. Like
Yeah.
I was looking at like the best black seed oil. I was trying to figure that out like a few weeks ago. And it's really interesting because the best black seed oil comes from Ethiopia. And there was this one company, and they had, I don't know whoever did their website. It was the best website in terms of tracing of materials because you could see there was a certification, what field they came from, where they were processed, what processing in Ethiopia was done. When it got transferred to the manufacturer company, they tested it, right? And it was all
Wow.
stamped by 17 different things. And you like go, these people are serious. Like, and then it got imported into the United States, and then there was an importation test, and then we put it now in bottles, and now we're going to test it again. And this is the only thing we make, and da 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 da. And this is like, they did such an amazing job. I'm like, okay, they've won me over for life.
Yeah. Yeah. Oh, I know. I want to know what that brand is because I got a friend just coming back from Ethiopia. Tell her to bring me some.
Would you really say? I don't know why. Ethiopia apparently has the best black seed oil and the best opals. This is all I know.
Amazing. Actually, I've noticed there's some supplement companies out there that are now testing every batch that they make, which is also quite interesting. So that you're not like, oh, I have the certification that generally we're manufacturing good things, but batch per batch, they're showing. Now, again, I'm hoping this is true and this is not just some made up certification, but that's a trend I see with some newer supplement companies coming out there. And that's reassuring at some point.
Yeah, yeah, yeah. Yeah,
Cool.
it's a process, and we'll figure it out. I hope.
Yeah, yeah. So, oh my gosh, we covered so much, but one last, and I keep saying one last, this is really the last one. And I think you know about this company that I've spoken about a lot called Nuchido, and they use nicotinamide, and that's the precursor of the NAD salvage pathway. So I'm wondering, because I have to go back. I should have had their list of ingredients, but I'm wondering if this is also a great option to the NMN and NR as well, because I think in this company they also have Apigen in the bottle. I have to go pull up the ingredient list. But are you familiar with Nuchido?
I don't know what's in their product, to be perfectly honest with you.
Oh, shoot. I should have sent it to you. Okay. Yeah, because the way that this has been marketed is that it actually fixes your own NAD factory, right? Before putting in the raw materials like the NMN and the NR, well, let's make sure that salvage pathways are really working so that you can actually get even more benefit a bigger boost of NAD from your precursors that you're putting in.
It sounds like, and they may, I don't know who these people are, and they may laugh. We naturally have NR in our bodies, and we naturally have NMN in our bodies. So these aren't made up molecules. And obviously, we have NAM in our bodies, which apparently was what they're putting in there. I have a funny feeling that NAM is cheaper than NR, which is patented, and or NMN. It sounds like a cheaper alternative for production.
Hmm. But NAM, so you're saying NAM is that
NAM is nicotinamide.
nicotinamide? It's also okay, you're
So
calling it NAM.
NAD gets broken into nicotinamide and then
Yeah.
goes to NMN, which then goes back to NAD. So
Yeah.
essentially, they're just choosing a different precursor.
Ah, okay. Okay. And maybe it's a cheaper than, and
Maybe it's a
then,
super precursor. But the other thing I will tell you is too much NAM is toxic. It's a negative feedback loop to certain parts.
mhm.
So don't take too much of it. It's just another one of the precursors. So I'm sure it's efficacious and I bet it's cheaper. But
Yeah.
that's
And they've got EGCG in there as well.
well,
I'm going to send it to,
then someone did their research, right? Because then that's great. EGCG, as we know, works with the enzymes, and apigenin is fantastic. Someone did their research. That's
yeah.
smart.
Yeah. Oh, okay. I'm going to connect you to Dr. Nicola Conlon, who created this. She's
Probably like,
fabulous.
yeah, I'm smart. I'd be like, great, you're smart.
No, okay. So, all right. This has been such a great conversation and a real eye opener to me. And I think we did get a little technical in the beginning. So I'm going to have to remind people the intro to get your pen and paper because you've explained some different pathways. And I think it's really important to know those and digest them a little bit. But we got a protocol going and I think cleared some confusion and then ways to protect ourselves. So is there any last words or things you'd like to share before I let you go?
I think we covered a lot. We'll just have to do it again when I know more, and we'll continue the conversation.
Oh, awesome. Well, I'm going to have links to in the show notes to how to find you on your website, kaufmanprotocol.com, and your books, Why We Age and How to Stop It, and then the aging solutions. And then you got another book coming out yet or no?
I'm working on books 3 and 4. Yep.
Wow. Oh my God, exciting. Oh, by the way, because you have an amazing rating score for molecules. What is the NAD or NMN and R? Do you have that in your books? I don't remember.
Oh gosh. Yeah, you know what? It's in book 1. I don't actually remember. It rates very well. I'd say it's 0333. Yeah, I don't remember, but it does.
Okay. It's in the book and it's rated and it's got a good rating. So that's good. That's already said something.
Caveat to that is when I wrote book 1, there was only NR. There was no NMN. We didn't know anything about CD38 really.
Mhm.
So one might say it's outdated and remedial, which is why book 3 and 4 are on the way. But the
Cool.
baseline information is in there.
Awesome. Okay. You better go get that book because you got a great stack and things to take as well based on your needs. And it's such a great read. And you write, you're so funny, actually. Your books are really entertaining. So it's not
Thank
just biology here. It's really great and easy to read. So anyone who wants to reach out to Dr. Kaufman, I've got your Facebook, your Instagram, and your website. Thank you so much for your time. I always have so much fun with you and learn a ton. So I hope to see you again.
And you will. Thank you so much.
And thank you to everyone else who's made it to the end of the podcast. So have a good day, good night, good morning, wherever you're at.